Okay, this is Paul, and on the bench today I have this handy fan, which is, I'm not sure, probably a 1940s electric fan. It might even be earlier than that, since it says it's designed for alternating current. Turn of the century fans back then, the early 1900s, could have ran on direct current. But this one is rated at 105 to 115 volts, 60 cycles, and it was made by Chicago Electric Manufacturing Company, and you can see the information there, and patent pending. So there's no patent number for me to run to get an accurate date, but the customer has this fan in for some repairs. The first being this bracket here that holds the cage onto the motor was broken off here and here. That was actually a continuation wire that went around and across the front. And what I did is I just wrapped some copper there to hold it in place. My thought being that if I duplicated this, which I did this one first, and it's not a very good looking way to do it. This is a better way. But my thought was to solder this copper, cover it with a coating of solder, and then paint it green along with the rest of the cage to match the base, condition it, or at least paint the joint green. There was another complaint with the fan, and that is that it runs too fast, and we'll look at both of those, and I'll give an explanation as to why it runs too fast. Let me get a container here to hold up this voltmeter so it doesn't fall over, and you'll get to see that when we get to that point. This seems to be holding fine, and I can tighten that up. It's a simple matter of recrimping these connections here and the other one over here that lock into the grid, the cage grid assembly here to hold it in place. I did oil this fan, so it runs pretty quiet. But the other complaint that the customer has with the fan is that it runs too fast. And I want to do a little short discussion as to why that's the case and what the issue is. And it applies to a lot of antique fans. But first off, I wanted to do a demonstration of the fan running, showing that it doesn't hit the cage, so the customer can see that, and also can see the potential fix that I had in mind there, and decide if that's appropriate, or if he wants to try to find another cage or a better way of solving the problem than I can come up with. My thought was, if we were to go with something like this, again, it would match, and I could try to make it look a little neater so that it actually matches the style of the cage. And once it's soldered silver, it'll hold it in place better, less likely to slip off. And then painted, it would look more original. And if that was an option that the customer wanted done here and here, then what about matching it here and here? Even though it doesn't need it, it would make it look uniform and more like factory work once it was completed and painted and all. It would also protect against these possibly breaking in the future, because they would be supported. But right now I want to do a demonstration of the fan itself. Unfortunately, I use my smartphone as my camera here, and when I'm running the fan, it's blowing air right across the microphone, so you're going to hear noise if you don't lower your volume. I'll probably lower the volume on my video editing software before I upload this to YouTube. But what I want to demonstrate is, one, that the fan doesn't hit the cage, that it does run fine, and that this would be a good good mechanical solution. Whether or not it's appeasing to the eye remains to be seen, or practical for the user, for the customer. The second thing I want to address is the issue with the speed. And for that, I'll have to turn the fan on and off so you can hear what it is that I'm trying to describe in this video. But first, let's do a demonstration of the fan at a low voltage. The voltage will be somewhere around 80 when I turn on. I got it connected to my Variac box there. So we'll go ahead and turn it on, and you won't hear no audio from me until I turn it back off. So turn the unit on, get it started since it's on a low voltage. Okay, I'm right at 80, 81 volts. And at 80 volts, this fan runs really nice. You can hear the armature slide in and out a little, but that's normal because it is an older fan. I have oiled it. But as you can see, the fan doesn't hit the cage. It's just normal motor sounds. Okay, and some of that rattling is because the cage is loose. Like I said, I have to tighten these clips. I didn't want to do that until I'm done with whatever I'm doing here, if this is the way we go. But that'll get rid of that rattling sound. But the other thing you notice is that the fan runs at a comfortable speed at 80 volts. The reason being is it's rated 105. If you can see that, if the camera will focus, there you go, 105 to 115 volts at 60 hertz, or 60 cycles back then. So at 80 volts, I'm down well below the turn-on range of the fan motor, and I would imagine that this is a centrifugal start motor, which has a starting coil, and that's why it wouldn't start at 80 volts. It has to have a little bit more volts. But the second demonstration I want to do, and I will do without speaking because it's going to make a lot more noise, is operate this at its desired voltage, which is between 105 and 115, and show you the difference in the speed of the fan in that range. So let's do that. Again, you may want to turn your volume down, but concentrate on the speed of the fan. I think what I'm going to do is take this cage off, just because it's kind of loose and I don't want it to slide off and hit the fan while it's running, and at the same time I don't want to fasten it. I don't want to bend these tabs any more than I have to, so I'd rather wait till everything is exactly the way it's going to be. So bear with me as I take this cage off, and then we'll do the test again. Okay, we're resuming our test. First, notice how quiet the fan is at 80 volts. Okay, now I'll be bringing up the speed. Okay, that's 95 volts. See, that fan is really spinning. We'll bring it up to 105. So there we have about 105 volts. Normal operating for this speed. This is the low end of the range. Now watch as I bring this up to 115. Okay, they were about at 115 volts. And you can see that that fan is really moving. In fact, even with a weighted cast iron base and being on a carpeted pad, it's still traveling some, just from the sheer velocity of the fan motor. Now, here's the issue. If I bring that up higher to 120, the fan is turning a little bit faster. Okay, I don't know how much of that you might have heard, but basically what the issue is with these fans is they are designed for a lower voltage than we have today. Currently in my shop, I'm pulling around 121 volts. That is determined by your distance from the transformer out on the power pole, the electric company. At 121 volts, this fan is running at full speed, but it's consuming more electricity. More current is going through the coil. This is not an ideal situation. The fan is peaked out, and it is running too fast because the power rating is, the power supplied is too great. If I could get it down around 100 volts, this fan would run ideal, which is about the middle of its range. 115, it's running fast. 120, and this fan is consuming way too much power. This is, going to keep it running really fast all of the time, and it probably would pick up a little speed depending on where this is adjusted, up or down. And the more, right now it's uphill a little bit, as you can see here. If this was level, then there'd be less pressure on the armature against the bearing, and this fan would even spin faster. And so this is not ideal, and this is a problem with antique fans. One of the solutions that most of the fan collectors suggest is operating a fan like I'm doing here with a variac. And by using a variac, you can control the voltage. That's ideal, and you can get standalone variacs that are, about the size of one of these containers here. That would power an antique fan and do a good job, and you have speed control as well as limiting the voltage to the range of the fan. However, most customers who own fans don't understand that part of the situation, and they plug their fans into their AC outlet and they're pulling 120 or 123 or somewhere around there, and then their fans are overheating, they're running too fast, and the armature coil or the strata coil the coils can burn out in the fan. The wires could burn out, the coils could burn out. They're not designed to run at that range. Now they are designed, most of antique fans are designed for plus or minus 5%, but that's pretty much off the center voltage. So in this case, that would be off about 107, plus or minus 5%. It'd give you that about that 100 to 105 to 115 range. Once you get over that, you're going outside the safety margin of the fan itself. This is just part of the problem of our technology today. Our line current is different. Obviously, if you take this fan to Europe and plug it in, you'll blow it away as soon as you plug it in, because they run on 220 volts. So, electricity changes over time, and electric ratings change. And the negative side of that, aside from the fact that you have to control the speed of the fan and protect the fan, you want to protect your investment as best you can, is you have to buy an external device to regulate the voltage. The other negative side of that is, or a consequence of that is, it really pushes the market for the lack of a better word, crappy devices that we have today that have no quality and do not have any longevity, usually made overseas with cheap parts made out of plastic, don't use real bearings, stainless steel bearings, have a lot of other issues that are just going to wear out, and that's what makes these items so desirable, is their quality and the craftsmanship that goes into them. I mean, the blades themselves are metal. Try to find a fan today with metal blades. But, this is what you have to deal with. However, the voltage requirement of the fan, of these older fans, is lower than what we have. So it's a trade-off. It's a catch-22. You have to protect your device and at the same time, be able to use the device in a safe way. This goes well beyond just grounding issues with polarized plugs and cables that can handle the power, but for now, what I tell folks is if you have an antique fan that has any kind of high-end value at all, run it on a rheostat, run it on a what's called an auto transformer, like a Variac or a similar device. This gives you two advantages. One, it protects the device from too much power draw and overheating, and it'll extend the life of the fan. But two, it'll help with controlling the speed, because as we've seen here, I can drop this fan down below its range, and it's not going to hurt the fan as long as the startup voltage is enough to start it. To give you an idea on that, and let me do a demonstration there. Again, you won't hear me for a minute. You remember at the beginning of this video, if you watched the whole video, that I started at around 80 volts and I had to get it turning by hand. At this point, we'll start it at 85 volts. Okay, it started, it's running fine, but it started a little sluggish. That's not good either, because in that case, if it has a starter coil to start the motor, that coil is engaged all the time. It's usually disengaged by centrifugal force. If that does not disengage, that starter coil will burn up. It's not designed to run the fan. It's only designed to get it going, and then it expects to be shut off before it overheats. So you're getting a crash course in how fans work here. I'm going to start it, raise it, shut it off, and we'll try it again. Okay, now we got the voltage set around 95. I'll stop the fan. Okay, and if I turn the fan on at 95 volts, it starts right up fine. So 95 volts is a safe spot to run this fan. Now once the fan's running, I could actually drop it down to 85 volts and it'd be fine, because the starter coil is already disengaged. Once the fan motor gets up to speed, the centrifugal force expands the starter connections and the starter coil is no longer engaged. Then you can lower the speed of the fan because it's already spinning and drop the voltage. You wouldn't need to. 95 volts, this fan's running slow enough that it's comfortable, there's no issues. So with a Variac, you could run this fan at 95, and at that case, you're 10 volts below the low end of its range. which means you're going to extend the life of this fan considerably, and at the same time have it running at a slower speed that's more comfortable than the high speed that this fan runs. Again, that requires an external device. But anyway, I just wanted to give you an overview of this little fan for two reasons. One, because of its voltage rating. It's a prime candidate to do this kind of demonstration. It's in a lower range than what we use today. And also, too, because of its size. It's small. It's able to sit on my desk right next to my voltmeter, and I can do the demonstration. And my other reason for doing this fan, like I said at the outset, was for the customer, the owner of the fan, to consider, a possible way of connecting this cage back together. I mean, you could take this cage to a very good welder. He'd have to be a very good welder. And he might be able to weld that on without blowing the metal to pieces with his with the welding stick. But would it last? How long would it last? You got a lot of pressure on this connection. In fact, this doesn't just comfortably sit in this position. It had to be held in the position while the wire was wrapped around it. So, these are things that you have to consider. You'd have to weld one side and make sure it holds really well, and then stretch it out to weld the other side. And I don't know that I would go that, and then the expense of a welder doing that and all. I'm thinking solder and some copper. This happens to be 16 gauge copper wire here. If that's too obtrusive or too large, it probably could be dropped to 14 gauge, which would look a little more pleasing but give a little less support. Wouldn't go lower than 14 gauge. I'm sorry, this is 14 gauge, 16 gauge. I wouldn't go less than 16 gauge in diameter. You get down to 18 gauge wire, it'd be a little bit too flimsy to actually have enough support to hold the cage together under the tension. So anyway, that's where we're at. And I just wanted to make this video. It's a little lengthy, I apologize for that, but maybe it'll help somebody who's struggling with what to do with a fast fan or what the options are. Thank you for watching my video.